welcome to another video. I'm your teacher, Mr. Flynn, and today we're going to be focusing on calculating percent composition. All right, now if we look at a water molecule, it's made up of hydrogen and oxygen, but you'll be quick to recognize that oxygen is much heavier than hydrogen is. And so when we're working with a sample, we want to know, well, what's the percentage of hydrogen that's found in this sample? Well, we can calculate that, and that's based on using our understanding of the masses of hydrogen and oxygen and relating them together to find a percentage. All right, so let's go ahead and write this in, okay? So these notes got moved around a little bit, so I'm just going to erase that. It should be over there. So when we're thinking about water, it's H2O, and the mass of hydrogen, of two hydrogens, is 2.02 grams, okay? And then the mass of oxygen is 16.00 grams. All right, and this is the total for our water molecule because we're considering there's two hydrogens and one oxygen. So the mass of H2O, or our molar mass that we just talked about in previous videos, is 18.02 grams. And what we're going to do is relate, okay, 2.02 to 18.02 and 16 to 18.02, and we're going to find that relationship. And when we type them into our calculator, what we're going to do is do 2.02 and then divide that from 18.02. And then that will give me a value of 11%. Okay, in my calculator it comes out to be 0.11, but we want to work with a percentage. So what we're going to do is just convert that by moving the decimal over twice. So that's 11%. Now let's do the next one. So we have 16 divided by 18.02. We're just taking the part and relating it to the whole. That's all we're doing. And if you notice, 16 to 18, that's a much closer value, so it's going to be much higher. So it's going to end up being, oh, I did that wrong. We do 16, and then we divide it by 18, and that gives me 89%. And that makes sense, because 11 plus 89 is 100, because these are two parts of a whole. And so if we add them together, it ends up being 100%. And so if we were to do a calculation and we had this much water, I wanted to know, how much of that water is hydrogen. Like if I wanted to collect the gas out of that water, I could actually calculate what that is because I know that it's 11%, or the oxygen, which is 89%. All right, so when we're thinking about measuring the composition of compounds or molecules, we got to realize that atoms come in different masses. And so oxygen is definitely going to be more of that mass because it's heavier. It doesn't mean there's more oxygen, it just means it's heavier, right? Because in this example, oxygen, there's only one oxygen and there's two hydrogens. So just because it's higher, it doesn't mean there's more, it just means it's more massive and that it takes up more space and it's heavy, okay? All right, and in the next example, okay, we can take this a step further, okay? So let's do this problem. So it says calculate the mass of hydrogen and oxygen in 98 grams of H2O. So you have a given. We have 98 grams of water. So let's put this here. So our mass is 98 grams of H2O. All right. Now our molar mass of water, right? We've already calculated this. It was up here at 18.02 because we think about the mass of water is the two hydrogens plus the oxygen, so it's 18.0 grams. All right, and then now we have to calculate our percentage, which we already did. We take the parts from the whole. All right, so the hydrogen is 11%, and the oxygen is 89%. All right, now this is where we apply our percentage to the actual value we're working with. So if I have 98 grams of water, how many grams of hydrogen do I have? And so what I do is I just multiply it, okay? So I do 0.11, and then I multiply that to 98, and that gives me a total of 10.78 grams of H2. All right, and this got bumped again, oxygen. All right, now for the oxygen, I take that 89% and I multiply it by 98. So remember, when we're multiplying again, we can't just type in 89. We have to type in 0.89. We have to convert it back into a decimal. And then I multiply that to 98. So 0.89 times 98 gives me 87 0.22 grams. And to do a little check, we can always add them. So 87.22 plus 10.78 gives me a total of 98 grams, which makes sense because that's what we're working with. We're just trying to see what part of 98 grams of water is hydrogen, and that came out to be about 10 grams. So if I'm in the lab and I separate the hydrogen and oxygen, okay, what I can find is that, well, if I collect 10 grams of H2, well, there's 0.78 that's missing, right? This is a theoretical amount where this is what should be there, and I can compare in my lab what I actually earned and see how close I got to the mark, okay? If I was collecting how much oxygen there was, well, there should be 87.22. But if I end up only getting 80 grams, well, there's 7 grams missing somewhere, and it may have got lost as the experiment ran on. Or it could have been part of a side reaction, etc. But this is just to calculate that theoretical amount, okay? All right, so this is for calculating the molar mass of an element from percent composition. And you can do this with any combination of elements, right? You can work with those and break them down until you get to how much there is of each, okay? Thanks again for watching. Until next time.